Imagine you have a metal with an unknown identity and concentration that you need to identify. Well, you can use a method called inductively coupled plasma optical emission spectroscopy, or ICP-OES for short. But first, you need to know about line spectra. When an atom's energy is increased, the electrons want to move to a higher principal energy levels. However, those electrons want to be at their ground states, or the lowest energy possible. They release the energy in the form of photons, or light. The color of light depends on the wavelength of energy released. This creates a line spectrum of all the possible colors for that element, and every element has a unique spectrum. These spectra can be used to determine which element an unknown metal is. Furthermore, the intensity of the light can tell you the concentration of ions. ICP-OES is one of the best methods of finding a line spectrum of an unknown metal. It involves injecting a sample of metal into argon plasma, which causes the electrons to become excited, then relax, emitting photons. The photons are then diffracted out into a line spectrum. Plasma itself is the fourth state of matter with an energy higher than gas. The gaseous atoms have been stripped of their electrons, forming a soup of electrons and positive ions. There are some atoms that are not ionized, and they remain in excited state, emitting photons that create a distinct spectra. Plasma is created by heating argon gas with high-energy radio waves inductively coupled to the argon. The first few atoms become ionized, and loose electrons begin flying around, knocking away other electrons and creating more ions. Eventually, a plasma 10,000 Kelvin is formed. When the sample metal is injected into the plasma, there's enough energy present to excite the electrons and create a line spectrum for the sample, which is used to identify the element. The concentration can also be determined by looking at the rate photons are emitted compared to a calibration curve. The curve is useful because there can be variations in light intensity based on changing conditions in the plasma. Intensities of sample lines of known concentrations of the element are compared to the intensity of your sample. Each element has its own calibration curve for each line on the spectrum that determines the intensity of the light emitted based on the concentration, or vice versa. The calibration curves are determined by finding the light intensities of known concentrations. The calibration curves are usually linear. This is also an extremely sensitive method of determining concentration, which is why it is most widely used. In conclusion, ICP-OES is a way to determine the identity and concentration of an unknown element using